What I will cover today may be a little bit harder than the subject which we have been covering. That's about completing the square first before the trigonometric substitution. Let me copy the problem first. Evaluate integration square root of 24 plus 2x minus x squared dx. So 24 plus 2x minus x squared should be modified to progress further. What we want to do is we want to relate this with the form which we can use trigonometric substitution. To do that, we will do completing the square first. So it'll be something like a squared minus x squared, but in a harder format. So the excitation formula, you have to remember to do that. This type of problem is a plus b squared is expanded to a squared plus 2 times ab plus b squared, and a minus b squared will be expanded to a squared minus 2 ab plus b squared. So what's happening here is the number in front of b squared is half. Half of the number in front of AB. So what we want to do is we want to modify it a little bit. Let's reverse the order, and then we can rewrite that as x squared plus 2x plus 24. And we don't like minus in front of x squared. So we will take out minus, then it becomes minus x squared minus 2x plus 24. We switch the sign because we take out minus. Then we are going this reversing way. To do that, we have to do something. So this is minus x squared minus 2x. We think about the half of this number. So this is 1 squared and minus 1, and then plus 24, because root must be the same. So indeed, so when we think about this formula, so we will do this part first and then this part. So we will distribute like this, then that becomes minus open parenthesis x squared minus 2x plus 1 squared, which is 1, minus will make plus. So plus 1 plus 24. So that becomes minus x minus 1 squared plus 25. Any questions so far? Is there any Wi-Fi issue today? I think in the chat, there seems to be a Wi-Fi issue on campus, maybe. I don't know. So anyway, it'll be recorded. It is recorded, right? And it'll be available later. So we can rewrite this as 5 squared minus x minus 1 squared. And then what you will think about is, well, we had cosine square root of theta plus sine square root of theta equals 1. From there, we thought about 1 minus sine something, right? And so the substitution will be 5 sine theta. So let x minus 1 equals 5 sine of theta. And then dx is 5 cosine of theta, d theta. Any questions so far? So what I was saying was the way we converted the given expression is we converted that into a squared minus, let's write large x squared. In that case, the substitution is large x is 5 sine a sine of theta. So that's the way we modified the original one. Let's go to the problem again. Then integration square root of 24 plus 2x minus x squared dx. So that equals integration square root of, as we did, 5 squared minus x minus 1 squared dx. What we did was we decided to put x minus 1 as 5 sine of theta. So That is integration square root of 5 squared minus 5 sine theta squared. So 5 squared sine squared of theta. We already calculated dx. dx is 5 cosine of theta d theta. So this is 5. So 5 integration. This one, we can take out 5 squared, right? 5 squared, 1 minus sine squared of theta. So we can rewrite that as square root of 5 squared times square root of 1 minus sine squared of theta. We already wrote this one here. So we write cosine of theta d theta. So square root of 5 squared is 5, and 5 times 5 will make 25. Integration. What is this? This one, by the Pythagorean formula, that is cosine squared of theta. So we have square root of cosine squared of theta times cosine of theta d theta. So we have 25 integration. This one is cosine. Cosine times cosine is cosine squared of theta d theta, right? So what can we do from here? We have degree 2 and nothing else is outside. So we have to think about the half angle formula. Half angle formula for cosine goes like cosine squared of theta equals cosine of 2 theta plus 1 over 2. So that is 25 integration cosine of 2 theta plus 1 over 2 d theta. Then that becomes degree 1. So we don't have any problem, right? We will put 2 in front of integration. Then that becomes 25 over 2 integration cosine of 2 theta plus 1 d theta. And then we have, that is 25 over 2. When we integrate, there is 2 theta, so we have to divide by 2. And that becomes sine of 2 theta plus integration of 1 is theta plus c. So what should we do here? Of course, everything is related to theta, but unfortunately, 2 theta is not easy to convert to x-related expression. So we will use the double angle formula. So we will use sine of 2 theta equals to sine of theta times cosine of theta. So we go here and then 25, That equals 25 over 2. Instead of sine of 2 theta, we will write 2 times sine of theta times cosine of theta over 2 plus theta plus c. Any questions so far? So this 2 and this 2 will cancel each other. And then we have 25 over 2 sine theta times cosine theta plus theta plus c. So the format of the problem is somewhat similar to the problem you worked out yesterday. So the last step is we have to replace theta by x-related expression. So we will go back to the point where we did substitution. X minus 1 was written as 5 sine of theta. From x minus 1 equals 5 sine of theta, we get sine of theta equals x minus 1 over 5. That comes from opposite over hypotenuse. So we will draw the right triangle. Like this. This is theta. Opposite is x minus 1. Hypotenuse is 5. And this side is not hypotenuse. And so hypotenuse squared minus x minus 1 squared. So 5 squared minus x minus 1 squared. So that equals square root of, this one is 25 minus open parenthesis x squared minus 2x plus 1. So that is square root of 25 minus x squared plus 2x minus 1. That equals square root of 24 minus x squared plus 2x. And that'll be used to describe cosine. So now we can do substitution. So from here, we can say that theta equals sine inverse of x minus 1 over 5. So here we can do substitution. So 25 over 2 sine of theta is x minus 1 over 5 times, we have to write cosine of theta by looking at the right triangle. Adjacent over hypotenuse, so adjacent is square root of 24 minus x squared plus 2x over hypotenuse is 5 plus sine inverse is theta is sine inverse of x minus 1 over 5 plus c. So this one will make 25. And when we multiply with this one, that'll be 1 over 2 x minus 1 times square root of 24 minus x squared plus 2x plus we multiply with this one, then we get 25 over 2 sine inverse of x minus 1 over 5 plus c. So that is the end of 7.3. Any question? No question? Seven point four is about partial fractions. Integration of rational functions by partial fractions. What we will consider in this section will be rational function. Consider integration p of x over q of x dx, where p of x and q of x are polynomials. There are a number of patterns with this kind of rational function. So we will deal with case by case. The first case is when the function is improper, meaning the numerator's degree is higher than the denominator's degree. So case one is f is improper. That is, degree of the numerator p is greater than or equal to degree of q. In that case, what we will do will be we will do long division and split the fraction into two pieces, polynomial part and fraction part. So strategy, we will do long division to convert p of x over q of x to s of x plus r of x over q of x when degree of r is less than degree of q. Let's work with the example. Evaluate integration x cubed plus 64 over x squared plus 64 dx. This integration fall into this case because the degree on the numerator is 3 and degree in the denominator is 2. So degree in the numerator is larger than the degree in the denominator. So we want to do a long division. When we do long division on the right side, we will write what's on the numerator, and on the left side, we will write what's in the denominator, which is x squared plus 64. But when we do long division, we start with the highest degree term, and then just we go down one by one. If there is no degree 2 term in the given equation, then we will write down as 0.x squared. If there is no degree 1 term, then we will write as 0 times x plus 64. So x squared, and then we have to multiply by x to get x cubed. And so we will do distribution like this. X squared times x is x cubed, and 64 times x. So we will write that right under x term. So 64x. And then we will subtract. So those two will cancel each other. And for this part, that is minus 64x plus 64. So if you look at this, this is degree 1 and this is degree 2. This became higher, so that means the denominator, when we split, denominator's degree is higher. So the way we write the given fraction x cubed plus 64 over x squared plus 64 will be, we write this, so x plus, we will write this one in the numerator, minus 64 x plus 64 over x squared plus 64. If you look at this format, and then when we think about integration, when you differentiate this, you will get just a 2x, but without this term. So we will rewrite this one as x minus 64x over x squared plus 64 plus 64 over x squared plus 64. By the way, you cannot cancel these out because 64 are the same. So what we are thinking about is a integration dx, and then integration from parenthesis dx, integration dx. And then we will do term by term integration. So integration x dx minus integration 64x over x squared plus 64 dx plus integration 64 over x squared plus 64 dx. So this part and this part will be calculated separately, and then we will combine those two. Let's put that as star. So the first thing, so this is the first calculation. This will be second calculation, and then we will combine all those. So integration, we have 64x over x squared plus 64 dx. So the denominator u becomes x squared plus 64, and then du equals 2x dx. Right, so from here, we can say that that is 32 times 2x over x squared plus 64 dx. And this denominator becomes u, and 2x dx, this one becomes du. So this one is 32 integration 1 over u du. And that is 32 times natural log of absolute value of u plus c. So that is 32 times natural log of x squared plus 64 plus c. Any question about this? All right, the second one, we have to use tangent inverse formula, integration du over a squared plus u squared equals 1 over a tangent inverse of u over a plus c. Okay, so we have second one, which was integration 64 over x squared plus 64 dx. Then that can be written as 64 integration 1 over x squared plus 8 squared dx. So that can be written as 64 over, just we are using this formula. So a equals 8. So over 8 tangent inverse u became x. So x over a is 8 plus c. So When we simplify, that becomes 8 tangent inverse of x over 8 plus c. So we will combine all of those. Then the first integration was x squared over 2 minus the this one was 32 natural log of absolute value of x squared plus 64 plus the next one was 8 times tangent inverse of x over 8 plus c. So that is the desired answer. Any question about this? For the next problem, the next pattern will be when the denominator has larger degree and the denominator can be factored into the linear factors, which are all different. But when I explain all those things with examples, I will lack of time. And so this will be the last example I will present today. If you have any question, then you can remain, otherwise you can leave.